when we begin. And for those of you who wonder what's going on, the students from the CSSA, the Cognitive Science Students Association, are hosting a zombie movie night in a couple of days with not just zombie movies, but zombie games, and for all I know, zombie popcorn. For those of you who are looking for a major or looking for a double major, if you major in cognitive science, you get to do stuff like this. So it's a good thing. Okay, as far as cognition goes, the social perceiver really has three basic problems that he or she has to solve. The first is the problem of impression formation. That is, forming a mental representation of the social stimulus to which you're responding. The people, the environment in which the people are in, and the things that they're doing. The second thing you have to do, and this flows naturally from the problem of person perception, is to categorize the social stimuli in the environment, a process that is basically a matter of making a similarity judgment, making a judgment that the things you're encountering now are similar to some things that you've encountered in the past. And the final thing you have to do is engage in a process known as causal attribution, which is basically a term that we give to causal explanations. People need to explain social events, which really boils down to providing reasons that are sufficient to explain why certain events are taking place the way they do. Once you've formed an impression of the situation, once you've categorized it in terms that are familiar to you, once you've explained what's going on, then you know what to do. That's the general idea. What we're going to focus on for the next couple of days is this causal explanation process as a kind of proxy for all the other kinds of social judgments that people make. Okay? This is causal attribution has gotten a lot of attention in the social cognition literature, and that's what we're going to cover. Okay, the framework for the traditional study of causal attribution, as almost everything else in social psychology, is provided by our old friend Kurt Lewin and his formula, sometimes known as Lewin's grand truism. Behavior is a function of the person and the environment. So that's basically a scientific statement about causality, and it gives us what we would call the Lewinian framework for causal attribution. You've got some behavior that you observe in the environment, and you want to explain why that occurred. Lewin's already taught us that behavior is a function of factors that reside in the person and factors that reside in the environment. So the Lewinian framework basically gives you these two choices for explaining behavior. Fritz Heider, another important early social psychologist, another like Lewin, like Ash, another person who came here as a refugee from Hitler's Europe, was the first person to talk about how people make causal attributions in the social domain in a couple of important papers and books. And basically, he adopted Lewin's framework for this business. He says, look, there's behavior to be explained, and there are basically two possible causes of the behavior given to us by Lewin. Something about the person, that is something about the person who's engaging in the behavior, or something about the environment, something about the situation in which that behavior takes place. Draw your attention to the title of Heider's 1944 paper, Social Perception and Phenomenal Causality. Heider wanted to make it clear that in talking about causal attribution, he's not interested in what really caused people to behave the way they do. That's a scientific task, okay? What he's really interested in are people's perceptions of the causes of behavior. He says that's what they react to. It's the perception of the behavior, including the perception of its causes. So he made a distinction between actual and perceived causes of behavior. Determining the actual causes of behavior is the job of the professional psychologist acting as a scientist. Dealing with the perceived causes of behavior is the job of the ordinary person on the street acting as a kind of naive psychologist. And so that's basically the idea here. Harold Kelly, psychologist at UCLA, took Hyder one step further, actually took Hyder several steps further and said, okay, look, if the social perceiver is acting like a naive scientist, maybe in trying to explain events, he or she goes about that task of causal attribution pretty much the way scientists would do this. And in science, in cognitive science and cognitive psychology, social psychology, we have a statistical framework for constructing experiments that allow us to vary independent variables and observe their effects on dependent variables and thereby work out causal relations in the real world. And so what Kelly decided to do was to try to adapt this professional scientific enterprise for the work of the naive psychologist, and basically took as his model for causal attribution a statistical technique known as the analysis of variance, which is something that you learn about if you take a statistics course. This is not a statistics course, so you're not going to learn it from me. Except to say that in the analysis of variance, we take multiple observations of behavior. We try to manipulate some independent variable and observe the effects of that manipulation on some outcome known as a dependent variable. And Kelly basically said that the naive person, the ordinary lay person walking around in the ordinary course of everyday living, does something very similar, trying to infer causality from the covariances that he or she observes in the environment between one variable and another. So this model of causal attribution gets this name, the covariation model. So Kelly begins by saying, look, let's go back to Hyder, let's go back to Lewin for a second, and it turns out that there are, when an actor does something to a target in a particular context, that gives you three principal causes of behavior. Either something about the actor caused the behavior to occur, something about the target caused the behavior to occur, or something about the context caused the behavior to occur. In the terms of the analysis of variance, these would be known as main effects, because you have an actor variable and a target variable and a context variable, and these have main effects. And then there are joint causes, what are known in the analysis of variance as interaction effects, where maybe it's the combination of the actor and the target, particular combination that led to that behavior, or a particular combination of target and context, or whatever. You can see that given three main effects, there are four possible interactions. Three two-way interactions, and then this three-way interaction. And Kelly said, let's just assume that people operate like this. Okay, so here are the possible causal outcomes. Okay, you can say John did something. John went to the zombie movie. Why did John go to the zombie movie? Well, there's something about John, something about the zombie movie, something about the context in which John went to the zombie movie, or whatever. So that's the outcome. Now, what's the information? Kelly argued that basically there were three different kinds of information that served as inputs to a covariation calculus that would generate as an output a causal attribution. And the first of these is the consistency of behavior, of the actor's behavior towards the target across contexts. Okay? If the consistency is high, okay, then the actor always behaves that way toward that particular target. John never sees a zombie movie that he doesn't go watch, okay? Or he only watches George Romero zombie movies, or something like that, okay? Then there's the distinctiveness of the behavior across targets, referring to the distinctiveness of the actor's behavior in context. Does John go to just zombie movies, or does John go to any movie that he runs across? So again, the distinctiveness of the actor's behavior can either be high or low. And then finally, there's the consensus among actors. Don't look at just John, look at everybody else. John goes to the zombie movie. Does everybody else go to the zombie movie? Is the consensus among actors high? Everybody else does the same thing. Or is the consensus among actors low? Only John does this thing. So if you're doing your calculations, you can see that with 2 levels of consistency, 2 levels of distinctiveness, and 2 levels of consensus, you've got basically 8 possible combinations. And of course, there's an infinite number of combinations, but these are experiments that actually have to get done. So we try to keep the thing as simple as possible. So again, given this kind of information, consensus, consistency, and distinctiveness information, and a relatively small set of possible causes, the actor, the target, and the context, Kelly basically argued that across multiple observations of the actor's behavior, you can then infer why he or she did what he or she did, basically by doing a kind of naive experiment. It's a naive experiment because it's not being done by professional psychologists, but basically what we try to do is to vary one cause and keep the others constant, okay, and then see what happens. So we're going to use this particular example here, okay? John laughed at the comedian, which is a famous example in psychology. The behavior is laughing. That's what's to be explained, okay? John is the actor. The comedian is the target of John's laughter, and the implied context is some kind of performance. You go to a comedy club or you go to a nightclub or something like that. And so now what we want to do is to try to figure out why this happened. Okay, so why did John laugh at the comedian? Either because of something about John, okay, maybe he's in a manic phase of manic depressive illness, something about the comedian, maybe the comedian was particularly funny, something about the situation, maybe it was a club setting where you really have to laugh, or there's something about, say, John and the comedian, some kind of interaction, okay? Now, in these interaction terms, there are lots of these. Both John and the comedian would be necessary causes of the laughing behavior, but neither cause alone is sufficient, okay? So that's what these interaction terms look like. Okay. Well, Kelly laid all this out, but he actually didn't do the experiment to try to figure out whether people actually did something like this. This was left to a graduate student of his, Leslie MacArthur, who's now Leslie Zebrowitz. She's the person who did the baby-facedness experiments that we talked about earlier. And for her doctoral dissertation, she laid this all out in a series of experiments. So what she did was to construct a number of the stimulus materials, all of which describe some event, like John laughing at the comedian, and she varied consensus information with a preface. John laughed at the comedian, almost everybody laughed at the comedian, okay, or hardly anyone who heard the comedian laughed at him. Consistency information, John laughed at the comedian. In the past, John has almost always laughed at this comedian, or in the past, John has hardly ever laughed at the comedian. And then she varied distinctiveness information. John laughed at the comedian. John rarely laughs at the comedian, laughs at other comedians. That's distinctiveness, okay? Or John almost always laughs at other comedians. And then there's a control condition in which subjects were simply given the sentence, John laughed at the comedian, and tried to explain it. Of course, if you think about this for a second, okay, if I said to you, John laughed at the comedian, why did he do that? The first things you'd ask me is, well, what was everybody else doing? Was the comedian funny? How does he behave towards comedians? How does he interact with these comedians? That's exactly the kind of information you want if you're going to make a causal attribution, and that's the kind of information that's built into the causal calculus. Okay, so then MacArthur gave her subjects a set of alternative causes. All they had to do was check off in a little box, why did John do this? Was it something about the actor, something about the target, something about the circumstances, or some combination of causes? That's as far as she went, as far as those interactions go. Let's see how this actually works out. Case 1, okay? John laughed at the comedian, and the consistency is high. In the past, John has almost always laughed at this comedian, so his behavior towards the comedian is very consistent. The distinctiveness is low. John also laughs at other comedians, so it's not just this comedian, okay? And consensus is low. Hardly anyone laughed at the comedian. If I then ask you, given this information, why did John laugh at the comedian, what you'll infer is that it was something about John. Okay? Nobody else did it. It's got to be something about him. Okay, that's the logic of the covariation calculus, and it turns out that's exactly the judgment that people make. Given the combination of low distinctiveness, low consensus, and high consistency, you get people making causal attributions to the actor. So people actually do follow this covariation calculus. Let's do another example, okay? John laughed at the comedian. Let's keep the consistency high, okay? In the past, John's always laughed at this comedian. Now let's make the distinctiveness high where it was low before. John doesn't laugh at other comedians. He only laughs at this one, okay? And let's keep the consensus high. Everyone laughed at this comedian. With this pattern of information will drive the attribution toward the target, or at least that's the logic of Kelly's covariation calculus. And in fact, it does, okay? So here are attributions to the target, and people make those about 65% of the time with that kind of pattern. There are 4 of these cases. Here we are in number 3. John laughed at the comedian. Now let's make the consistency low. In the past, John has almost never laughed at that comedian. Remember, consistency has to do with the consistency of the actor's behavior toward a particular target. Distinctiveness remains high. John doesn't laugh at other comedians. Consensus remains high. Everyone laughed at the comedian. Under these circumstances, the logic of it drives the attribution to the context, something about the situation. Maybe everybody was drunk, or it was a wedding, or whatever it was, okay? And in fact, people do that, okay? What you can see here is that most of the attributions in this case are to the situation as opposed to the actor or the target. And then finally, in our 4th case, John laughed at the comedian. We make consistency high. In the past, John's almost always laughed at the comedian, so he consistently laughs at this comedian. The distinctiveness remains high. He doesn't laugh at other comedians. He only laughs at this comedian. Consensus now is low. Hardly anyone laughed at the comedian. And then, again, the logic of it is, well, there's got to be something about John and this comedian. Maybe it's his brother-in-law or something like that, right? That's causing him to do this because nobody else is doing it in this circumstance. So again, the attribution is to something about John's relationship with the comedian, the actor's relationship to the target. Now, here's the only place where MacArthur's experiment didn't really work out, okay? People just don't know what to do with this, that didn't know what to do with this in the MacArthur experiment. And the reason for that is I think MacArthur really just didn't allow for people to think about the interactions too much. Remember what her choice was, kind of something else or some combination of factors. And people just didn't do that. But 3 out of 4 ain't bad in social science. It turns out that the predictions of Kelly's covariation calculus were basically sustained in 3 out of 4 of these cases. And the 3 out of 4 that really count, where the logic says, given a particular pattern of information, you ought to drive attributions one way or the other. Okay, so that gives us what Roger Brown called the covariation calculus for causal attribution, where given multiple observations of behavior, okay, you try to plug in your observations in terms of consensus, consistency, and distinctiveness information, just varying it, seeing whether it's low or high. And depending on the pattern of information available to you, that will drive the attributions toward the actor or the target or the context or whatever. That's basically the idea behind this calculus. Okay? So that's the framework, the traditional framework for the study of causal attribution that Fisk and Taylor talk about, and that a lot of people have built their careers on looking at various aspects of this. Okay. Now, it turns out that once you get into the habit of making these kinds of thinking about causal attributions this way, it turns out that there are other things that you want, that you think you might want to consider. Bernard Weiner, who is Kelly's colleague at UCLA, was also interested in causal attributions. And he was especially interested in attributions about achievement kinds of behavior, school performance, for example. And he, in addition to thinking about consensus and consistency and distinctiveness information and attributions to the actor and the target and the circumstances, Weiner argued that when it came to achievement-related attributions, there were additional dimensions that you had to take account of. One was what he called, after Julian Roeder actually invented this term, but he derived it from Roeder's work, locus of control. That is the locus of control over the behavior in the environment or with the person? Is it internal or external locus of control? And then finally, his other dimension of attribution was the dimension of stability. That is the cause of the behavior something that is a stable feature of the world, or is it something that is unstable or variable? These two dimensions of attribution become important when you start thinking about attributions for achievement, because the various combinations of locus of control and stability give you the kinds of attributions that people make in achievement contexts. If I say to you, Judy got an A on the exam, okay, one of the things you want to do is try to explain that in terms of, was it something about Judy or something about the exam? Is it a stable feature of Judy or the exam, or a variable feature? And the combinations here now give you 4 different kinds of attributions about performance, whether it's academic performance or athletic performance or whatever. Ability attributions reflect an internal locus of control and a stable internal locus of control. Ability is something you've got, okay? It's high IQ, or you've got a lot of musical ability, or you've got a lot of upper body strength or something like that. There's something about you, and it's something that is relatively fixed or permanent, and that's what an ability attribution basically involves. On the other hand, you've got external stable attributions, which have to do with task difficulty. Why did Judy get an A on the exam? Because the exam was easy, all right? So there, the cause is external, nothing about Judy. The cause lies in the world, in the exam, but it's a stable feature of the exam. Exams either hard or easy, okay? And that's all there is to that. But by the same token, you could have internal unstable locus of control, which is what happens when we explain something in terms of effort. Why did Judy get the A on the exam? Because she studied really hard. It's something she did. It's an internal cause, but it's an internal cause that is unstable. On one occasion, she might study hard. On another occasion, she might not study, and the outcome might be different, okay? And then finally, we've got a combination here of external locus of control and variable causes, which is basically just luck, okay? That's how luck maps out in the Weiner system. But if you think about this for a second, you know, the attribution that you make is going to be part of your motivation to behave the next time. If you say, well, you know, she got the A because of her ability, then the expectation is she'll continue getting A's. If she got the A because the exam was really easy, then you might not have those kinds of expectations. If she got the A because of effort, then she knows she has to study hard again the next time there's an exam. If she got the A just because of dumb luck, okay, then there's nothing she can do about this, okay? Here there are things you can do. You've either got the ability or you don't. The exam is either difficult or it isn't. You either work hard or you don't, or you kind of leave everything to chance. Okay, so Weiner's version of it's still a covariation calculus, because you've got these factors that are varying and co-varying with various outcomes, and where you see the some factor covariant with some outcome, you make the attribution accordingly. If you're thinking about this, and I'm sure you are, there is at least one other dimension of attribution that you want to think about, and that is the globality dimension, which is to say, does this attribution hold for lots of different kinds of outcomes, or does the attribution hold only for a relatively few kinds of outcomes? So if I say Judy got an A on the chemistry test, okay, the first thing you want to know is, did she get A's on lots of other tests, or is there something about chemistry? Okay, this third dimension in the Wiener system is very important because it underlies a very prominent theory in clinical psychology known as the hopelessness theory of depression. This is work by Lynn Abramson, Lauren Alloy, and their colleagues over the last number of years, who have tried to propose a cognitive theory of depression as a kind of correction to the prevailing biochemical theories of depression. Basically, to make a long story short, Abramson and Alloy argue that people are rendered vulnerable to depression not by virtue of some piece of their biochemistry, but by virtue of a particular style of thinking, which Abramson and Alloy call attributional style. And she argues that whether you tend to make internal or external attributions, stable versus unstable attributions, global versus specific attributions, your tendency to make attributions along these lines, your leanings, your bias, if you will, may render you vulnerable to episodes of depression. And what they call the depressogenic attributional style basically refers to a person's tendency to make internal, stable, global attributions concerning the outcomes of behavior, especially negative outcomes of behavior. Internal, I'm responsible, not something external to me. Stable, I'm always this way, it's not anything I can change. And global, I'm this way about everything, okay? That pattern, if you have negative outcomes, it happened because I'm stupid, and I'm always stupid, and I'm always going to be stupid, and I'm stupid about everything. If you start making attributions like that, you're going to become depressed. So this tendency to make internal, stable, global attributions about events, especially negative events, they called a cognitive diathesis, that then interacts with stress. If something bad happens to you, again, what you want to do when something bad happens to you, you want to figure out why. And the answer that you get, the attribution you make, is going to determine whether you get depressed about it or not. If something bad happens to me and I make an internal, stable, global attribution to it, this bad thing happened because of the kind of person I am, I've always been like this, and it's always that way with me. Depression is almost a logical outcome of that. But if you make an external, stable, global attribution, you don't get depressed. Maybe you get paranoid. The whole world's against me, right? But you don't get depressed, right? So again, you've got this idea that a pattern of thought, a habitual pattern of thought, is going to have consequences for your mental state. Yeah? Yeah, well, in their world, things are on a continuum. But what Abramson and Alloy find is that there are big individual differences on these kinds of things. And there are certain people out there who, whenever they try to explain an event, tend to make internal, stable, global attributions about that event. And there are other people who don't do that. And then when they follow them up, it turns out that the people who have this depressogenic attributional style tend to be at risk for depression. So what you try to do in these kinds of things, of course, everything really varies on a continuum, but you just establish cut points, okay? So somebody who gets classified as having depressogenic attributional style, would make internal attributions more often than external attributions, stable attributions more often than variable attributions, global more often than specific. Yeah, there would be some variance there, but the tendency would be to behave like that. That's the general idea. Yeah?
On the other hand, if you have internal, stable, global attributional styles for positive life events, does that make you confident? Like,
Yeah.
I may on the test because I'm awesome, I would have been awesome, I would have been awesome.
That's right. That's exactly what it would do. And of course, the trick is then you're not going to study for the next test, right? And you're going to fail, and you're going to, then you have to say, oh, geez, maybe I'm not so awesome after all. But that's right. Okay, the idea is that there's going to be these interesting attributions that people make. Marty Seligman, who was the mentor of Abramson and Alloy, has actually argued that there's a kind of depression that people get when good things come to them for no reason at all. Okay, you know you're not responsible for these things. You're happy that it's happened, right? But people like to be responsible for the good things that happen to them. They don't like to be responsible for the bad things that happen to them. But when you make, say, external stable global attributions about events, you know, well, geez, really, there's nothing I can do about any of this. Right? So that's in fact what happens here. So anyway, the point of this is that all of these things, Weiner's framework for attributions in the achievement context, MacArthur's work, and for that matter, the hopelessness theory of depression, all stem from this basic idea of a covariation calculus where people are behaving like naive scientists trying to abstract from multiple observations of various kinds of outcomes what's causing the outcomes to occur. In the Kelly framework, is the outcome due to something about the actor, something about the target, something about the context? In the Weiner framework, is the outcome due to internal versus external factors, stable versus variable, global versus specific, and so on. Okay. Now, that's not all there is to causal attribution. There's a lot more to it than that, even in this traditional framework. And Kelly argued that in addition to the covariation calculus, in addition to the basic calculation of causal attributions given consensus, consistency, and distinctiveness information, that there are other kinds of principles of causal attribution that came into play. And let's just go through these very quickly now. The first is you don't explain everything that happens in life. Okay? The events that we want to explain are the ones that are surprising, that violate our expectations. Okay? We also want to explain events that have serious consequences. Okay? So we don't go around, you know, every time I see a leaf flutter off the tree, I don't stop dead in my tracks and say, oh, I wonder why that happened. You know? But you know, if my cat ignores me in the morning or my wife yells at me or something like that, well, that's not surprising, but bad example. But if my cat ignores me, for example, then I said, gee, you know, why is Fedora doing this? You know, maybe I didn't feed her or something like that. So we try to explain things that are surprising. Okay. Our explanations tend to have what Kelly called a contiguity bias. There is a tendency to think that causes and effects are close to each other in space and time. Now that's not necessarily the case, okay, but we have a general view of causality that leads us to look to nearby events as explanations. Okay, why did she yell at me? Well, I did forget her birthday, or something like that, right? I don't look in been married 25 years. I don't look back in 25 years ago for the cause. I look back to something I might have done yesterday or the day before. Representativeness bias. We have a general tendency to expect causes to resemble their effects. There ought to be some kind of similarity between causes and effects. If I say, gee, why did my wife yell at me yesterday? It's probably not because I didn't feed the cat, or something like that, right? It's got to be something something about her relationship with me. So there's a general tendency to do that. There's a discounting principle that goes into operation, which is that when behavior corresponds to what situational demands would expect, then we tend to discount personal causation. Okay, if a student at Berkeley gets A's on exams, we say, well, you know, all Berkeley students get A's on exams. It's not so special. It's nothing special about him. So we discount any contribution that he or she as a person might make to that outcome. By the same token, there's an augmenting principle in play, whereas when people engage in behavior that is contrary to situational demands or is just not expected in terms of situational demands, we tend to augment the role of personal causation. And then finally, there's a motivational bias in causal attribution, which is that we tend to assume that people do things in order to maintain self-esteem and also to behave in an appropriate way. So these are add-ons to the covariation calculus. It's not just a matter of plugging in information, but the covariation calculus comes first, and these other things come into play later on. Okay. Whether it's the covariation calculus or the Weiner framework or the Abramson and Alloy framework, so far we've been talking about people abstracting from multiple instances the information that they need to determine why some event happened. If I asked you, if I say, why did John laugh at the comedian, what you need to know is, how has John behaved towards this comedian in the past? So you've got to have multiple instances of John's behavior. You've got to know how John's behaved towards other comedians, and you've got to know how other people have behaved towards that same comedian. You've got to have a lot of information. We don't always have a lot of information. Sometimes we just have a single observation. And just because there's a single observation out there, we don't stop the causal attribution process. You observe something happening. You don't say, oh, gee, you know, why did that traffic accident occur? Well, I'm going to wait and see how many other times that person's involved in a traffic accident and how many other traffic accidents occur in that corner and how many other people have traffic accidents. You don't do that. You say, well, he turned against the light, or he was driving too fast, or whatever. So we do explain single events, okay? But we can't apply the covariation calculus to the explanation of these single events for the simple reason that the covariation calculus requires multiple observations. So what do? Well, Kelly argued that under these circumstances we rely on what he called causal schemata, that is, abstract ideas about causality, to try to make a best guess about what it is that's causing what. And Kelly went through and talked about a number of these causal schemata that I just want to describe for you. First, there are basically 4 of these that he talked about: multiple sufficient causes, multiple necessary causes, compensatory causes, and graded effects. Now, for all these examples, let's just assume an academic context for a second and talk about something like test scores or course grade or GPA or something like that, and you'll see how this works out. In each case, the causal attribution depends not on the pattern of information available to you, because there is no pattern of information available to you. Rather, your causal attribution is going to depend on a kind of naive or implicit theory about a particular domain. Okay, so for example, in the causal schema called multiple sufficient causes, the abstract framework is that there are lots of possible causes, none of which is necessary for the outcome to occur, but any of which might be sufficient. for outcome to occur. So, for example, think about college admissions, and think about the good old days back before you had to write all those essays and send in your YouTube video to Tufts and all those things that they require you to do now. Used to be a time when college admissions was basically based on your GPA and your SAT. Okay, if they were high enough, you had a good chance of getting in. If they weren't very high, you had a very poor chance of getting in. But the way that college admissions framework worked is that if you had a really high GPA, they didn't pay so much attention to your SAT scores. And if you had a really low high school GPA, they looked at your SAT scores to see if maybe you had some potential that wasn't being actualized. Here, there are multiple sufficient causes. A high GPA is, in this system, sufficient to get into college, but it's not necessary. A high SAT score is sufficient to get you into college, but it too isn't necessary. So what happens then is that you can kind of map out, if you know what a person's GPA score is and what his SAT score is, you can use this causal schema like multiple sufficient causes to explain the outcome of the college admissions process. So, for example, if somebody with a high GPA but a low SAT score gets into a good college, what you do is you say, well, you know, they didn't pay attention to the SAT score, they paid attention to the GPA. That's multiple sufficient causes. The more likely result, okay, is that somebody with a very low college, or a low GPA gets into a good school, and you say, well, okay, but they discounted that because he had a high SAT. Multiple sufficient causes, none of which are necessary, any one of which is sufficient. Okay, so there's a discounting principle that goes on here. It turns out that when one cause is present, people just tend not to pay attention to the other cause. Okay, if somebody gets into Harvard and they had high GPA, nobody says, well, what was his SAT score? They just attribute the admission to the high GPA. Okay, but here there can be augmenting. Okay, when one cause facilitates the outcome and the other one inhibits. Suppose we have a person who's got a low GPA that would inhibit college admission, but high SAT scores that would facilitate college admission. If we know he got in, okay, then we can augment the one cause. Okay, and the same thing goes for these other possibilities. Now, just to make the contrast here, suppose that you had a view that there were multiple causes, all of which were necessary for a particular outcome. Back here, multiple sufficient causes, there are multiple possible causes, any one of which is sufficient for the outcome. Here, you've got multiple necessary causes, none of which are sufficient on their own, all of which are necessary. This is basically what Bernard Weiner had in mind in his kind of naive model of achievement, where achievement is kind of a combination of ability plus effort. You can be the smartest person in the world, but if you don't use your brains, you're not going to achieve. Okay, so you got to have both of these things necessary. Okay, so now if the outcome is present, if the person passes or gets in, and you believe that these multiple causes are all necessary, then you can infer the presence of both causes. Oh, he got in, he must have had a high GPA and a high SATs. If the outcome is absent, but one cause is present, then you can infer the absence of the other cause. You can see here how your view, your theory of what causes what, allows you to make inferences about what causes were operative and what causes were not operative. Here's another example, compensatory causes, also one that's very familiar in the achievement domain. Here you've got multiple causal factors, but instead of just being present or absent, they vary in strength. So if the outcome is present and one cause is weak, then you will infer that the other cause was strong. You see this when people, especially in education, talk about overachievers versus underachievers. Underachiever is a person who should do well in school but doesn't, okay, has the ability but doesn't necessarily have the effort. Overachievers are people who don't have much ability but get by through sheer effort, sheer force of will. So you've got somebody who's not too smart, who does well in school, okay, you know that the ability cause is weak, you infer that the effort cause is strong. Again, this only works if you've got some theory about what causes what in a particular domain. And, you know, it all depends on the domain. You'll have a different kind, you may have a different theory. It's not the case that there are people out there who have, say, a multiple sufficient cause schema for everything that they see, but you might have a theory of a domain that involves multiple sufficient causes and a theory of another domain that involves compensatory causes and so on. One more, okay. Ooh. All right, graded effects. Here again, you've got multiple causes that vary in strength, but we no longer have a dichotomous cause, a dichotomous effect. We don't have getting into college versus not, passing the course or not. Now we're looking at something that varies along a continuum like course grade. So again, if the outcome can vary in strength, okay, and the causes can vary in strength, then again we can make inferences about what caused what, knowing where some of these, knowing where the causes lie. If a person gets very high grades, okay, and take another example, a grade of A might be sufficient, but you might get that by virtue of high ability and high effort. A grade of B you might get by virtue of low ability and high effort. You might get the same grade by virtue of low effort and high ability and so on. So again, depending on the nature of the effects, whether they're dichotomous, present or absent, or graded, the nature of the causes, whether they're dichotomous, present or absent, or graded, you can make inferences even from single observations about what caused what. Okay. Last thing I just want to say here is that the big difference between the covariation calculus of causal attribution and this idea of causal schemata is that the covariation calculus is abstract. The idea behind the covariation calculus is that in any domain you want, academic achievement, athletic achievement, mating achievement, hostility, aggression, anything at all, if you've got consensus, consistency, and distinctiveness information, you can plug that into the calculus and it'll tell you whether the behavior is due to the actor or the target or the context or some combination of those things. It's an abstract framework for making these kinds of judgments. But causal schemata are not abstract. Causal schemata are domain specific, okay? You've got to have a set, to use these various causal schemata, you've got to make some assumptions about, not just about causes in general, but also you have to make assumptions about causes in particular. You may think that academic achievement is a product of ability and effort, okay, and use one of those causal schemata to explain academic achievement. But if you think that achievement as a piano player or as a tennis player or a golfer or something like that, really you've either got the ability or you don't have the ability. That's a different theory in a different domain, and that's going to dictate what kind of causal explanations you have. So again, causal schema is very abstract. The covariation calculus is very abstract. Causal schemata are not abstract at all. They're very, very, very concrete, domain specific. Okay, next time we're going to talk about the role that language plays in causal attribution. Thank you very much. Have a good weekend. Try to stay dry,